In this video, we're just going to do some more examples of using separations of variables to solve differential equations. So in our first example, we have dy dx is equal to 3x squared y. So what we do is, again, we move the dx to the other side, and then we're going to bring the y over here. So what we'll have is 1 over y dy is equal to 3x squared dx. And then taking the integral of both sides, we have the integral of dy over y equals the integral of 3x squared dx. And so what we'll get is the natural log of y plus our constant c, I'll call it c1, is equal to x cubed plus c2. And I'll leave it to you at home to go ahead and check the calculus there. Make sure you're getting everything the same thing that I am. And then once we do this, we get natural log of y is equal to x cubed plus d. So I just move the constant over, or I'll just move c1 over to the same side as c2 and just call that d. And then lastly, we have to exponentiate each side. So we get e to the natural log of y is equal to e to the x cubed plus d. Now when you're doing this, a lot of times people fall into a trap where they might say this is equal to e to the x cubed plus e to the d. And you can't do that. You have to make sure that you remember to exponentiate the entire right-hand side, not just each term piece by piece. So we'll go ahead and cross this out. Okay, and then further simplifying this, we get y is equal to e to the x cubed, e to the d, and I'll just call this term right here a. And then we get y is equal to a. So let's look at another example here, and I'll just go ahead and use a different color for this one. So let's say we're given dy dx times x is equal to 1 plus y. So first, let's move this x to the other side, and we get dy dx is equal to 1 plus y over x. And so now we can go ahead and separate our differentials here. So we'll get 1 over 1 plus y dy is equal to 1 over x dx. And we can integrate both sides again. And we'll get the natural log of 1 plus y plus c1 is equal to the natural log of x plus c2. And then simplifying this a little bit, we get the natural log of 1 plus y is equal to the natural log of x plus d. And then solving for y, you get 1 plus y equals e to the natural log of x plus d. And then y is equal to e to the natural log of x plus d minus 1. And we can simplify this. We can say y is equal to e to the natural log of x, e to the d minus 1. And so this will just become x. So we'll get y is equal to e to the d times x minus 1, or simply just y is equal to some constant times x minus 1. And let's go ahead and look at one more problem here. Suppose we're given dy dx equals y squared x. And we're also told that when x is equal to 0, y is equal to 1. So y of 0 equals 1. So we can go ahead and separate both sides, and we'll get 1 over y squared dy equals x dx. Let's go ahead and integrate both sides. The integral of 1 over y squared dy equals the integral of x dx. And then negative 1 over y is equal to x squared over 2 plus c. So solving for y, we multiply y by both sides, so we get negative 1 equals y times the quantity x squared over 2 plus c. And then y is equal to negative 1 over x squared over 2 plus c. And let's go ahead and get rid of that fraction in the denominator. So we multiply by 2 over 2. And this tells us that y is equal to negative 2 over x squared plus 2c. Or, since 2c is just another constant, y is equal to negative 2 over x squared plus d. So we're given enough information now that we can actually solve for d, because we're told that when x equals 0, y equals 1. So let's go ahead and plug that information in. So 1 is equal to negative 2 over 0 plus d. And to solve for d, we just multiply both sides by d. We'll get that d is equal to negative 2. So then our full solution is going to be that y equals negative 2 over x squared minus 2. So I hope this video was helpful. Go ahead and do me a favor and hit like, and I hope you have a great day.